So thanks, Arndt, and hello, everybody. Isn't this a great conference? Yes, it is. So much goodness about UI5, right? So let's add some more of this goodness. My name is Andreas, and as Arndt said, I'm the product owner of the team UI5 Core and Runtime. So you certainly heard about UI5 Evolution today, right? At a couple of occasions, also this morning in the keynote. And there was some practical session also with Arndt and a colleague about the asynchronous APIs. So you also know what's behind UI5 Evolution. It's the innovation project for UI5 to solve today's problems, but also to advance the framework, the tooling, and the controls. So I briefly had in this teaser during the keynote the goals. So let's use that as a starting point. We want your apps to be fast. Of course, all the apps that are built with UI5. And for doing so, we want to have the code more modular. But not just more modular, it's also about cleaned up code, concise code, code that you really like to work with. And when working with code, you want to make sure that it gets or becomes more future-proof than it is today. So look for standards like asynchronous module definition, as we do, and for other things that are on the horizon and start as emerging technologies. And to be able to integrate these emerging technologies or even integrate with other projects more easily, we are becoming more open. And of course, as an open source project, we're also giving back to other projects and technologies ourselves. So the toughest part very often when developing is to keep your code in a compatible way. And that's also what's quite a major task for us and requires many efforts. But to us, it's also an opportunity because then we can ask you to go with us on that route of UI5 Evolution and also keep improving your code, but starting from an application that doesn't break just because there are improvements in the framework. So what does this yin-yang symbolize? Basically, that's what we have to do to achieve our goals, and we can only achieve them together. And that's because we need, on one hand, to think Evo, and on the other hand, to really use Evo. And what's meant by that? The think Evo part is the mindset, the right mindset to do it, and to be open and get familiar with the new concepts. And the use Evo part, that's actually the right feature set to use, or even the new tool set to use that we saw this morning. And the good thing with the think Evo part is, well, if you haven't started already, I guess you are starting today because of the input you get from the different sessions and also from this talk here, I hope. So don't wait. Look into the material you can dig up after the conference, get in touch with people, get in touch with other colleagues, and see that you start to improve thinking about your application code and what you could do on your side already. Because there's a lot of API in the existing framework, so there's no need to wait. On the other hand, we're working quite hard, as I said, mostly because of compatibility, to do all the new stuff and provide new means, new async API, new features, new build tooling to support your changes. Also working on tools that make it easier to migrate your code eventually, all that kind of stuff. So it's really worth the effort, even if it's tough. So the challenge itself, or starting point, is that UI5 has, of course, a lot of features, but it's a rather monolithic code. So that needs to get broken up. And that's what you already saw in the keynote. It's about a new restructuring of the framework, having distinct layers in there, and really think along a layered architecture. And with the 4 major parts here, we will concentrate on the modular core part, and possibly also an outlook to bundling features that will eventually end up in the build tooling. So the modular core is the foundation, right? It's to become the future-proof foundation of all the work you will do and all the improvements that we implement. So basically what we try to become is a collection of bricks. Think of Lego bricks or some entities that have a value by itself and kind of work independently. So we really went through the code in the framework, starting with the core part, introduced asynchronous module definition, rewrote all the stuff, made sure that dependencies are declared explicitly and that there isn't some implicit magic that somehow allows the applications to work, or the framework parts. And also started to get rid of all the globals. And that's one of the key takeaways for you. If you're still using globals, accessing API in a global way, that should be used via a clear module definition, then start right away and get rid of those, because that's one of the obstacles to make a real move into the future. But it's not just to make finer modules. It's also about thinking, where do these modules belong to? And there are modules that don't actually require to depend on a DOM or jQuery. So why should they be right within the lowest levels of the framework or the core? They don't have to be there. So we started to have only modules in the lower part of the core that are independent of the DOM and jQuery. So for such a low-level part of the core, that it's still kind of small, but it's going to increase also feature-wise, you could use that part and run it in a browserless environment, right? Like Node.js or even a web worker. And you could use it to do some pre-processing on the server, something you could do upfront before actually deploying your application. And the good thing about thinking about a separation to jQuery is, if you don't have it in the lower levels of the core, maybe your upper layers actually don't need it, as we saw for the web components approach, right? That's kind of an alternative or something on the side. So for the regular UI5 programming model, of course, you need a lot of stuff. But in some scenarios, probably you don't need even jQuery, right? A couple of years ago, we couldn't think of that, but nowadays, there isn't much need for that very often. So let's see how the modularization took place in the core part. So the starting point are the existing apps, and of course the framework that is shown here up to UI5 version 152. So their code uses many modules that are in a jQuery.sap namespace. And each of those modules is rather large. And moreover, many apps don't access these modules in an AMD-like way, but depend on globals. So it's it's not the best starting point, but something we need to address, right? So that's what happened with 154. So the modules were already split into smaller pieces, and they were refactored and separated into those layers that I mentioned. For one, a base layer that isn't dependent on DOM and jQuery, and on the UI layer that has all the required features. So in order to have all the existing code to continue to work, we introduced a compatibility layer that provides all the API that existed before. The new modules that we introduced in 154 are in the code base, but they have a disclaimer and aren't meant to be used directly. That still holds for 156, where they are still internal, but they have been improved over time. But what we did with 156 is also that we introduced a stubbing layer that takes care of potential global usage or usage of globals by having lazy stubs that cover this legacy API. But that wasn't also not shipped with 156. So it's becoming increasingly exciting when to get there, right? And that's with 158. So with 158, you see the three arrows to the right. And as the traffic light colors kind of indicate, that's also a level of maturity of your code. So the green one is the preferred one, the one you should work towards to. And that's accessing the new modules directly without any compatibility layer. Applications that use the old APIs, but did it without missing some dependencies, they just keep working through this compatibility layer. Those are the yellow applications in this picture. And even the applications that didn't care really about dependencies and they just happen to work implicitly due to some internal dependencies that were there. They continue to work because of this stubbing layer. So don't worry about the changes we do underneath. There might be large, but we always think about how to mitigate potential issues and how to make sure that your apps continue to work. Nevertheless, if you want to stay up to date and future-proof and take advantage of any new features that UI5 brings, you are urged to go along with us and get rid of all the legacy API that hinders that progress. So in the green arrow to the very right, even for scenarios where you only need to access the base layers, you should be able to write an application eventually. Right? So that's quite a bright future. Talking about asynchronous APIs, if you attended, for instance, the best practice talk of Arndt and colleague, you might have seen many of the new APIs and also ask her to look into that, use that. We introduced new harmonized factory APIs, really some elegant APIs next to the already existing async APIs. So look into that, use that. That will be really a benefit. I don't want to go much into detail why we all should rather use async APIs than sync ones, but just to recall, we all need to get rid of sync XHR, sorry, synchronous XHR. And that comes along usually with synchronous API. And that just blocks the main thread. You cannot execute code in the meantime. You cannot do other requests. Content security policy doesn't really work because you need a script execution, all that kind of stuff. So that's legacy. That's what also browser vendors identified, and they started to deprecate synchronous XHR. That's why you maybe noticed already this deprecation warning in some of the dev tools. They might never remove it because there is so much code base out there, also outside UI5, that relies on that. But nevertheless, if it's marked as deprecated, let's get rid of that. And what you see quite often, also in the UI5 code, well, the most elegant way to deal with asynchronous coding is by using promises. If you aren't that familiar with it or with the APIs behind it, do it. It's a really good investment. All right. So let's complete the picture of the modular core that we had with exactly those asynchronous APIs and the new possibilities, loading components, views, controllers, all that kind of stuff. We also introduced in 152 optionally a way to do asynchronous XML view processing. And the UI5 loader actually started to show up as well. You'll see in a minute. And that's the way to go for all your asynchronous module definition. Well, and by having such a cleaned up code base, we are able to embrace many tools and features that the web brings, for instance, for bundling, using Webpack or others. That's a good starting point. So talking about such emerging technologies, there were questions this morning already about ES6 or ES6 modules. Yeah, well, that's a future step even beyond AMD, right? But if we do the first step right, why shouldn't we go such a step in the future as well? So we want to keep evolving, right? It's not just one effort and then it's done. So we're just starting to be there for a long time. And that includes also the overlap into the tool chain that allows us to take such technology and use it within the regular UI5 app development flow, even that it's not part of the framework itself. So you have a chance to include such a feature if you think your app really benefits from that, be it ES6 or TypeScript, for instance. All right. So let's look at the module loading. And here you see the situation in 152. And there is the red box with the jQuery sub declare and jQuery sub require. So short question, who's still using this API in a project? I can't believe it, right? If that's true and almost no hands went up, then it's great because it's deprecated API, right? You should, for long, already use the version sap.ui.define and the require variant. So that's good. But with 152, all those requests were done in a synchronous way. And only the preloads, they could work with in an asynchronous way. So with 154, it's the first time that UI5 loader really shows up as a distinct artifact, right? And that's really great. So we split off the legacy part that was behind the jQuery sub global. It didn't even have a separate loading part in the framework, right? It was buried underneath. So that was split off, an interface introduced, and we could expose this new asynchronous UI5 loader. And of course, it still worked synchronously inside, but with some experimental tweaks, you could manage to get it into asynchronous mode. But it was hard. And with 156, it's much easier because now it's your best friend for loading modules. And you could use a public config API, use an async flag set to true, and there you go. Then it tries to run in asynchronous mode. Of course, there's still a sync fallback if you need. And why not have not just colorful boxes, but some demo, right? So let's see how the UI5 loader looks like. Well, that's just the snippets. And here's my mouse. And as it says, welcome to UI5con, that's some artificial intelligence here, right? Okay. So what you see up here is there really is a UI5 loader.js that lives in the framework now, and it's requested here. And in the section down here, you see that using the SAP UI require, we have the core.js get requested, and then some usual stuff attached in it. You all know about that. And up here, it requires a button. Right? And with this config section up here, I can now turn on async to true. What I can also do is, if I want to get closer to other AMD loaders, just like require.js, they have define and require exposed on the global object, right? And I can turn that on. So we provide now global require and define calls as well. So if I turn that on, I can change my API, just get rid of the prefix, and see if it still runs. There you go. So it still works. So it's an increasingly AMD spec compliant loader we have. It doesn't have all the bells and whistles. So if you need certain extensions, you know, from other loaders, we might not be there yet. But if your project wants to work with such an AMD style loader, try it out and see how far you can go. For productive applications, we still suggest to use the sap.ui.define. All right. There you go. So we saw the loading aspect. And what's very important, it's not just loading all the individual modules now in some asynchronous way. That's not the major benefit just by itself. It's rather that if we all together are able to have this asynchronous loading, we have more possibilities, more options for requesting parts of an application that is needed at some later point in time, do some better bundling because we have a clean code base. And if you joined the talk of Matthias and Merlin this morning about the UI5 built-in development tooling, they already showed 2 versions of bundling that ship with the new UI5 tooling. And that's basically the preload and the self-contained. And I guess many of you were in this session. It's just a matter of a single line on the command line interface to get to such a result if your code base is ready for that. Right? So to the left, you see that all your application code gets bundled. In this case, it's the OpenUI5 sample app that gets into a component preload. And each individual library is packaged into a library preload file. Right? That's not bad, right? But it's not so good for an application that doesn't need much of a library, that only needs part of a library. So why would you load the entire one? So if you have many controls in sub.m, right, why load all of them if you just require a fraction of it? So for a standalone application, it's much better to use the self-contained approach. That might be an application that you host on a mobile device within a Cordova container, or even request it from a mobile device. So there it's really crucial not to load code that isn't needed. And it's not just about loading. So if you think what the impact is of unnecessary JavaScript, so first you have to load it, right, with all the latency and all the disadvantages. Then it needs to get parsed. It gets compiled. Eventually it gets executed if that's still in your flow. And if it's executed, I mean, you aren't done because it creates objects, it uses memory, and that's really bad on mobile devices. So the fastest bit of application code is the one that you didn't have to load and work with. And the size difference, of course, depend on your application, but they can really be significant and can really make a difference. So that's what's available today and what you actually saw today, this morning. Maybe give me a hand if some haven't seen the demo during the tooling part. A few people. Just let's do that quickly, because even if you saw it, that doesn't hurt to see it twice. Right? So that's the preload version of the sample app created just with a single command and the new UI5 tooling. And let me look for the mouse and then the dev console, typical workflow. There you go. Okay, let's reload. Maybe on the network tab. Okay, there you go. Here you see the two library preloads get loaded, of course, in an asynchronous way. And down here, it's the component preload of this very simple application. So that's not bad. So what about the self-contained bundling? How does that look like? Did it come up? No. Luckily, there are bookmarks. So that's the same application, but now created as a self-contained package, right? And there's just a single custom JS. Might be too small. There you go, right? There it is, much smaller. Of course, while that works really great for an isolated app, a standalone app, this approach for a self-contained bundle. If you have an integration scenario with multiple applications, like in the Fiori Launchpad, it's not that easy anymore, right? Because there you might end up with a better solution that uses the library preloads because of the caching and because there is much overlap between all the apps anyway. So it doesn't hurt that much if you take an entire library, because over time and working in such a user session, you might need most of the library code anyway. But it depends, right? And we're working exactly on such scenarios as well. So because the self-contained just works perfectly for such an isolated app, it doesn't mean it's not important also for other scenarios. And the good thing is, with a clean code base and a modular core and a modular application code base, you have all the options and all the prerequisites that are needed for better bundling. So because it has been shown this morning, and I went briefly into that, I thought about why not kind of giving an outlook what a modular core actually could allow us to do. And we're starting to look into such scenarios. So that's kind of an outlook into the future and options we look into. So for one, if you want to even further improve a standalone application and the self-contained build, if you could say during deployment time, if certain features you're interested in or not, or if you know about the environment that your application gets deployed into later on, and you could give that to the build tooling, it could optimize the code even further, right? Like, I mean, you could say what your target browsers are at all for a specific application. Of course, nowadays, with all the modern browsers kind of being aligned, it's not that much of a topic. But it might be if you could say, hey, for what platform you actually want to create this self-contained package. Is it for Android? Is it for iOS? And have different variants depending on your target platform. But you could also think about features in the framework. If we expose it and put it behind feature, like is there keyboard handling or any larger features in the framework that you could turn on and turn off, right? Just to get the size benefit, particularly on mobile. And you could also use such feature toggles yourself in your application code. If you have a variant of your application that is for a power user with a more complex user interface, some settings dialog that only such a user would require, why not have a specific application just for that kind of user? So the possibilities are kind of endless, and depending on the code size you can put behind such a feature toggle, the results are really significant. Just to mention something that goes into a similar direction but is out of reach right now for us because it needs ES6 modules. That's built in ways to even reduce code further. That goes by the name tree shaking, so many of you might have heard about that. It basically has the effect of dead code elimination, but it works the other way around. But the takeaway is that with a good declaration of modules and using ES6 modules, tools are able to just put that code into your deployed application that's actually needed by your application in a much more fine granular way that the modules would provide, right? So you even get below the module granularity. But that's just an outlook. What's quite in reach, I'd say, is if you look at such a full app and the code it requires. So why not use the code splitting also for a UI5 app and have just that part that is initially needed for the startup transferred and used to bring up maybe just the first few of your application. And then later on, if you go into other sections of the application, then you would need the remaining parts, right? And if you have many views and if you thought about how you could kind of progressively build up your application or how a user would walk through your application and your interfaces, you certainly get ideas where such split points are. And you could instrument such split points and take the tool chain take advantage of that information and create such other bundles that are needed later on. So that would significantly reduce startup time. And of course, it's not just this one remaining bundle that you need after the startup. There are different views, there are different ways to navigate through an application. So actually, it becomes a set of parts, and they share common parts and all of that. So it gets trickier, but there are solutions out there that already use that. And why shouldn't we use that with UI5 as well? Just stick to the define and require, have a clean code base, and I'll promise we get there together. All right. So actually, a slide I put in today because it's hot off the oven, I'd say, right? We're talking about core and what's the hot stuff. Actually, it's interesting that the temperature of the Earth's core is as high as the surface temperature of the sun, right? So actually, within the globe, right, there really is a sun inside, right? So how to bring that to the outside a little bit more. And that's just some experimental thing, thanks to one of our UI5 gurus, Frank Weigel, that looked into that as well. And if it's just to show you a hot demo here on UI5con, then it's actually worth it, right? And it's about getting to bundles without doing anything upfront in the tooling, but using native capabilities in the browser to do that for you automatically. So let's have a demo and click on this hot core. There you go. It comes up here. It always looks trivial, right, in live demos, but there's much behind it already. And what's the case here? I'll do that again. So you see, oh, there are many individual modules loaded right now, right? So that's not some kind of bundling, right? At least not from the dev console. Yeah. But the effect of HTTP2, if you provided some more information in your application, what's done here in this experiment, is that the multiplexing feature of HTTP2 can retrieve many such individual modules over a single TCP connection. So the effect is almost like loading a single prepackaged file. It does have some performance issue. That's what browser vendors and we in collaboration also look into. It might not be ready for productive use, but it opens up the way, for instance, for a Fiori Launchpad to also go that way and have benefits from bundling, even if within an environment that doesn't allow for such a single self-contained packaging. And just to show you how that could look like in the performance tab of the Chrome tools. Let's go there. Just start recording. Gonna reload the app. Stop. So just need to tidy up a bit. Maybe you can see it already. Right. So if you look down here, that's the network part. And if I scroll down, you see those cascades of individual modules being loaded. But if it's within such a cascade, it's over a single TCP connection due to this multiplexing feature, right? So that's, in effect, a kind of bundle, but it's created by native means via HTTP in the browser. And here to the right, you see some others of such dynamic bundles. So with all of those efforts of UI5 evolution, particularly in the modular core, having a clean code base and really asking you to go with us that route, we have many, many more options to really get to fast and really cool apps. All right. Takes a second, maybe. There you go. So let's wrap it up. So what did we already ship, and that you should really know, right? So first with 154, we promoted to use SAP UI define and require and deprecated the other ones already. We have the new internal modules. To be fair, that's just the jQuery.sap part, but the modularization efforts will continue and get to other larger modules in the framework as well. With 156, we start to have the stubbing layer, so applications don't break, even that we do much more modular work underneath. And to also decouple dependencies, we introduce the lazy instance of, so you don't have to require a module up front just to check in your code if an instance really belongs to such a class, right? So it gets decoupled by this lazy instance of, which is called isA. The more fine granular modules are going to be available with 158, replacing all the legacy stuff. And we also get rid of other jQuery.sap API that doesn't relate to modules itself. So you get to a better code base at the end. jQuery is removed from the lower layers of the framework and pushed into the UI parts. And for the asynchronous loader part, you saw that it ships with 154, and with 156, it's even more robust, and you can easily configure it and see how far you can get with it. And for the asynchronous API, we started early. With the XML template processor, you can switch to async behavior. And we replace many of the sync APIs throughout the framework code already with async variants. All right. We also strongly coupled the renderer to a control because de facto it was required together anyway. So we made this dependency explicit. And with 156 now, we also have those more elegant factory methods you probably use during your job every day, right? So use the new API. So that's basically it, right? Much information about the new stuff, but start to get familiar, think Evo, and then actually use Evo, and I'll promise it's going to be a great success, not just for the framework itself, but we want to have a great success with all of you together and for your applications. So thanks for listening, and think Evo.